some of the members of the Lead to Succeed interview group. During our time with Lead to Succeed, we learned about the water resources in our community. Specifically, we learned that jobs in the water industry are in high demand. So, for our Learning Service project, we decided to interview professionals in the water industry. They taught us about jobs that are available for youth with the proper education and training. We hope you enjoy and learn a lot of things. Thank you.
Smith is a manufacturer. Right now, our main products are water related in terms of water heating and water treating. Here in the United States, we manufacture water heaters and boilers, and environmentally friendly ones. And in China and in India, we're working on water treatment products that filter water so that people My role is actually a new one. Since January of this year, I am now the Talent Acquisition Manager for A.O. Smith. And what that means in simple terms is I help all of the human resource managers in all of our facilities find the best talent, help them in their recruiting efforts to find the best people and to hire them. The ones I'm always looking to fill are the highly technical roles, engineering positions and technicians. And I think what a lot of students such as yourselves don't realize are that technician type positions in an industry like ours are excellent careers, they're well paid, and they only require 2 years of training in a technical school like MATC. But I also look for engineers who have 4-year bachelor's degrees in electronic engineering, chemical engineering, mechanical engineering. Sometimes we even need them to have master's degrees, PhDs in that engineering space. High school internships in the past, yes, we've had some Lead to Succeed students work in our research and development facility here in Milwaukee. It's called the A.O. Smith Corporate Technology Center. We had one student who worked as a general helper in the labs, building shipping containers, doing some cleanup, helping a technician or an engineer run an experiment. We also had another Lead to Succeed student who worked in our water treatment lab, and she tested water samples for us and collected data and provided that data to the scientists who were working on the project. In this case, it was various types of membranes that filter water, and she had to test the water that came through these membranes to figure out what was in it. I think for any student such as yourself in any career, you really have to think about, what do I love to do? What is my passion? What do I enjoy doing on a day-to-day basis, whether someone is paying me or not? That's the best way to find a career. What is my bliss? What really makes me excited and makes me, keeps me up at night thinking about it? That's a good way to figure out what your career would be. If you like science and math, engineering or being in a technology career might be the way to go. If you like things like conservation and the environment and clean water, again, a field like this might be the way to go. But ultimately, you really need to pick a career that is something you enjoy. Because when you enjoy something, it's easier and you're bound to succeed. There's so many things. It's so exciting to be in Milwaukee because we are next to the largest freshwater body of water on the entire planet. And I don't think most people realize that the Great Lakes system, the 5 lakes in the Great Lakes, are the largest freshwater collection on the entire planet. No one else in the world has what we have. So here we are sitting in Milwaukee right next to it, and we're on the cusp of becoming hopefully the hub of the world for water industry. We'll become what Silicon Valley is to software. We'd like to become the world for water, and it's really fun to be right here at the beginning of this process, and hopefully it'll make the future in Milwaukee very different and much better.
basically, our project was made to inform teens and get them interested in water jobs that are currently available that they do not know about, which we didn't know about before we started this program.
I'm the laboratory manager. We run a quality control and testing laboratory. We test the various materials that come in here for the properties when we receive them, such as the oil content, any contamination of oil such as PCBs or solvents that may be added to the oil that would make them not a safe oil to use as a recycled oil. I test for heavy metals contaminations in the oil and the water. We also test various other things as a need basis. We might do ignitability. Say if gasoline got mixed into an oil, that'd be a dangerous situation that nobody would want to be working around. So we do a lot of that checking as the material comes in. As the material works its way through our treatment process, along the way, we again check the metals to make sure that our treatment's effective. On a daily basis, most often, there's two different categories of testing we do most often. One, on the waters, we test for heavy metals contamination in the waters. Metals are regulated in two ways. One is by the EPA. If they have too high concentrations of certain metals, such as lead and chromium, they become a hazardous waste. We would not even be able to accept that material at our facility for treatment. Metals are also regulated for the water we discharge to the sewer system. We have to get those metals concentrations down to a sub-part per million concentration. The only way to know that we're effective treating that is to test them. We use an ICP, inductively coupled plasma instrumentation to do that. We can test up to 18 metals. It takes about 5 minutes to run that test. So it's really an on-the-go treatment where we're getting real time. For the water, first we take a sample off the truck to test. We'll just stick with metal bearing wastewater. We test it for metals there. Then we'll do a bench treatment. We add our different chemicals, test the effectiveness of the different chemical ways to remove the metals. We will check the bench cup that we did in the lab to make sure the metals are removed effectively. Using that information, out in the main plant on the large 5,000 gallon tank treatment, we'll duplicate that treatment process, verify that it was effective there. We then move the water to the final staging tanks prior to discharging to the sewer, where we again test it to make sure it did not pick up any contamination throughout our system, whether it was running through a pump, through a line that was used to pump a different material that had some contamination. We hold it in that tank until we do a final verification of the water. We record the date, the time, the original generator of that wastewater, the volume, pH, and all the metals concentrations that were regulated on the discharge sheet. And at that point it's discharged, and that's the final test for the water. We take lots of water, millions of gallons, up to 2 million gallons a month of water. We reclaim from dirty metals contaminated, oil contaminated waters. We reclaim that water by removing the impurities from the water, discharging it to the MMSD. Ultimately, we discharge back into Lake Michigan, where it becomes a freshwater resource again for all the other companies and people living along Great Lakes region to make use of again. Mass waste has several different jobs available. As you saw, mainly today you saw the laboratory side of it, where we do the analytical work, testing, quality control. We also need truck drivers to transport the material here. They do more than just driving a truck. is when they get to the facility, they actually have to hook up hoses, clean out the tank, the material is, and all. So it's not just backing up and picking up a load. They do a lot more. They do cleaning. We also have treatment plant operators that physically unload the trucks, put the product into a tank, and do the physical treatment of the material to make the clean water and the recycled oil. Also, just have industrial service technicians. They will actually go to a company off-site from here. So the company has tanks that are dirty, they have machines that need cleaning. They have some issue at their facility that we are better off going there, doing the work, cleaning their equipment there. Also, as an industrial service, they do a wide variety of quite physical work, such as they'll do confined space entry, which in a law you're entering a tank or container that is not designed for somebody to be in. So there's a lot of hazards that are there, such as lack of oxygen, you've got chemical hazards, you could have just being trapped in the tank without no way of getting out. So it requires a great deal of additional training to do that. We also have general material handlers, we have maintenance people, both for the facility and for the trucks that we have. We need the mechanics to work on the trucks. As well as all that here, we have all sorts of what you'd expect at a general office. We have people that keep records, we have accountants, we have just all the things that are needed to run any business day to day. We have that in our other facilities up at West Dallas. We have about 20 people that work up there keeping track of all the records that are required to run this facility. It's a waste machining coolant. Find it has a high amount of water in it as well as oil. Oils are soluble in the water, so just letting them sit, it's not going to separate out. There's some special chemicals that have been developed for us that will help break these emulsions in the water. Up here, you can see that there was a layer of oil all mixed together. You can see it separating out here. And what we'll do is we'll allow that to settle. And just in a matter of minutes, you'll see this oil layer, that's going to pop off. We'll separate this oil off of here, and that will go to our oil side of the operations. With water here, we separate out. We'll use that as a separatory funnel.
Thank you.
Now we'll allow this to settle out. When we get back on the tour, we'll see how that's really separated out. Also within the compliance monitoring in here, other than sampling, we also need to monitor what we're discharging. To know what we're giving them before they test it and say you did a bad job. We need to know we're doing a good job. So that's what a lot you see here. It's you see we have a lot of duplication of instrumentation, all that. That's all quality control to back up. When something goes wrong, we have a backup.
Hi, I learned about STEM careers and that water stewardship is important, and we are trying to get other people to do it too.
The purpose of this project is to show how important water is.
I'm a senior project manager with MMSD, so my main role here is to manage and administrate the capital-related or O&M-related projects. And in addition to that, because I'm familiar with the wastewater treatment process, So we also look at the different unit treatment process to identify the area we can improve to reduce the energy usage on each treatment unit process, improve energy efficiency. Yeah.
I'm an electrical engineer, and my role is the controls of things. So I work on controls of our equipment out in the field, controls of our equipment at the plant. So like when to tell pumps to start, when to move valves, how to send that information from one place to another. And that's just a fancy graphic of our South Shore plant. So in there, overall picture of the plant, but what we do with this is we collect our data, and this is what I get to work on quite frequently, so this is what excites me. We collect our data and we've got it sorted by different categories. So if I were to bring up this is one of the areas where 7 channels come together. All of these gates are controllable. All of these meters tell us how much flow is going through it. These valves move to regulate flow. So we got a bunch of screens like this for all the stuff in the plant. We bring the information here, that's all live data you're looking at. And based on what things are doing, we tell valves and pumps and other equipment to do different things. For my degree, it's a 4-year program, electrical engineering. I took 5 years because I did a work-study program in the middle, so for some of my semesters I spent at an actual job site working instead of in school. And it extended my education by a year, but it gave me lots of good experience before I headed out into the job market.
I want to mention one thing as an engineer. See, after 4-year university education, you start your career as an entry-level, as an associate or assistant engineer, no matter it's an electrical engineer or civil engineer or environmental engineer. But based on my knowledge, after 4 years of work, you probably want to pursue your licensed professional engineer. By doing that, you show people you are licensed, you are qualified to do work more like independently, and basically as a professional engineer, you're able to sign on the drawings or the calculations or specifications you prepared. To the university education, you need 4 years of actual working experience to get a licensed professional engineer.
We do internship programs every year. Every summer we have a group of folks in the high school or college realm come in and work with various parties around the district. We've got folks that do kind of the hydraulics of the conveyance system. We have folks who do asset management, and MSD is a big place and we have lots of assets. All of our pumps wind up being assets, all of our instrumentation winds up being assets, so there's interns that work with those guys. So yeah, we actually get to work with high schoolers and college age kids yearly.
We had a little conversation about this, and I told Scott, I when I was in high school like you guys, I want to be a doctor, medical doctor, and I was choosing between medical doctor and engineer, and finally I chose engineer. There's reasons, because first of all, engineer, you only need a 4-year engineering degree, university education, and it's too costly to training to be a medical doctor, and also you can make a pretty good living by being an engineer. And why I want to choose to be an environmental engineer, because I was told by my parents, as an environmental engineer, you're the doctor of the earth. Instead of medical engineer, you're a doctor of one person. So that's basically how lead me into an engineer, then an environmental engineer. But yeah.
On a personal side, I've always felt that engineering is our big group of people who help make things happen. Like the circuits that run inside of computers, engineers figured out how to lay those out and make them work. The way we drive on the roads, engineers sit there and figure out what traffic's going to go where. I feel that we kind of help make things happen, and that's pretty exciting. We get to build screens like that, we get to hook things up, we get to figure out how things work, and then we make something useful out of it. So,
There's always something come out of engineering you can see. You can visualize it.
well, one of the big things about Milwaukee, and I don't know that we all have a great appreciation of how lucky we are. We have a huge source of fresh water right over there. And not all places across our country or across our world have fresh water access. You know, we've got all those oceans, but it's all salt water. So it's not, you know, you can't just take it and scarf it on down. Here we've got an abundance of water. We've got the 3 rivers running through Milwaukee. We've got the huge pond right out here. And this is one of the rare cities that is fortunate enough to reside on a freshwater lake. So we've got some responsibility here to keep our water clean, usable,
Yeah.
and drinkable. That's not us that does that part,
Yeah.
but we make it clean enough so that the drinkable folks can take it and make it into water. So
Yeah.
I feel that we have some responsibility here.
Milwaukee is a big, industry. We have breweries, and those breweries generate a large amount of wastewater. Those wastewater have high strengths of organics and have a lot of nutrients in there. So if you don't treat those and discharge right into the Michigan Lake, they're gonna generate trouble. Say if you have a lot of nutrients, you're gonna have eutrophication. I don't know if you learn anything from high school about eutrophication. Basically, it's excessive growth of toxic algae. So you can smell, see if you can smell really bad from the lake. That means, we don't want that happening.
Project was to put youth inside of a career pathway towards water industries. I have learned that water is way more important than you think, and you should very much.
Tests that we run pretty frequently on a probably weekly basis. Chlorine, really what we're testing for is, as far as this demonstration, what I set up here is I have deionized water, which we produce here at the laboratory. I have a sample of drinking water, which I did not take from the tap. I made this myself, but chlorine is a product of disinfection, and the DNR requires water utilities to maintain a detectable level of chlorine throughout the distribution system to prevent microbial growth. I also have a sample of pool water, which that demonstrate just how we would determine the concentration of chlorine in these 3 samples. In this case, I just had 10 mils sample each tube. We have a chlorine powder pillow. I'll be adding this powder pillow to a single powder pillow to each tube. You should see a color development. This is a colorimetric test. The intensity of the color will be indicative of the concentration of chlorine in the sample. Now, normally we would take this over to a spectrometer and run a single wavelength at a monochromatic light beam through the sample and determine how much was absorbed by the sample. So the deionized water should be absent of any chlorine, which it is. This drinking water should contain approximately 0.5 part per million. according to Milwaukee Water Works, chlorine leaving their facilities should have at least a part per million of chlorine. So it's understandable that by the time it reaches your tap, it may have a varying amount of chlorine, but part per million is pretty accurate. The pool water, just because of all the human contact, is going to have a higher concentration. So you notice it's darker.
Being a part of something positive shows forth that you're investing in yourself and those around you.